Today I'm going to try to build a class that creates a Curve3D on Godot. I'm gonna do it first from the editor, and I'm going to build it using a CSGPolygon3D and a Path3D. So the first thing I'm gonna do is try to build it from the editor, then try to figure out how to do it from code, and I'm gonna build it in the simple way first, then try to see how to build it using a circle as the polygon vertices for the CSGPolygon3D so that it creates a tube in 3D. So basically I'm just gonna follow the steps that I have here. As for the first one, just create and take notes of how to change the values from the editor of the CSGPolygon3D and the Path3D. Then I'm going to study the class, Path3D class, because I want to understand how to have the first part of the process is just building from the editor, then understanding how to set the values, then looking into the class on the source code to understand how to add the points from the source code. Then figure out, I'm probably going to use ChatGPT for this and search online on how to create the circle using the class from source codes. I don't think I'm going to do it the circle from the editor because it's just going to take a lot of time because it requires a bunch of points, I think. It's just basically creating triangles on a circle. Then if I manage to do all this stuff and create the class, which is going to be here up until this point, I'm going to look for how to implement the Bezier curve on C++. I forgot the name of the algorithm, but there is an algorithm, but that's people say that is the simplest one, which is just doing linear interpolation of points and doing that over and over again with the result of the previous iteration, and then that creates whatever Bezier curve you want. And I forgot the name. There's a name of, but I'm probably gonna search for this. And then the idea is gonna be to use the algorithm to generate the Bezier curve from the Path3D node. Then use that Path3D node with the circle for the CSGPolygon3D to create a Curve3D on Godot. Then if I manage to do all of this stuff, what I'm going to try to do is to remove everything from the classes, the actual math that they do, which I already looked superficially over. They just have a data structure for faces, which are 4 points probably of vertices that creates a mesh, or a piece of a mesh. Then they use that piece of mesh inside of the classes to create the geometry based on the Path3D node. So I want to see if I can extract everything and then put everything only on one function on the other class that I have. So I don't have to use these other two classes here. Then if I manage to do all of this, I'm going to see, depending on how hard it is, if I should create, I was thinking about creating another math library, not library, but math functions and classes for Godot, because it's not very intuitive to me the way that they do the matrices there. So I was thinking about translating or converting some matrices classes from another library into Godot, and then using those classes to build geometries and to study geometry in general. And one of the libraries that I found is this Geometry Central here, which is from this series of lectures. And there's another video that I found. If you search Geometry Central on YouTube, we're going to see. And I'm thinking about studying this library here because it's basically a playlist where he explains a bunch of things on mesh generation and curvature of surfaces and stuff like that. So I want to see, but it's going to depend on how hard it is to do all this stuff. So this is the path that I decided that is probably the best to go about it now. Because I was trying to convert from Blender, but I think that's going to be more productive to do this stuff. So, but first I'm going to, I think I'm going to do this, then I'm going to do some stuff on Enki there, because I didn't do it today. I think it's very simple. Pretty sure I did this on last stream. Just add the polygon here. Then you add a Path3D or Path3D nodes here. I think I tried to do this on the source code some time ago, and there is an annoying thing there, but we're gonna see. So I think here is where you add the points for the Path3D. I can see there, here. I'm just gonna add whatever points here. So I create a curve. That's whatever. So after you do this, then all I have to do is to change the mode here for path. Then you have to assign the path node here, I think. So I forgot I have to write down this stuff here. So basically, they log here everything that happens on the mesh every time it sets a value there. The way that the values are exposed here is using a macro called add property on C++. And every class on Godot is registered on another class called ClassDB, which is a class that they use. It's a global class, it's a singleton that they use to keep track of all the classes, all the types that Godot is going to use. And they have another one which is objects, I think this is object.db, but I don't remember very well. But I know that object slots is a global variable as well to keep track of all the objects used. So just the two main classes that they use to communicate with the editor. I see this on a bunch of streams, but I think that's it. If someone is new watching this, it's probably worth mentioning. And then the way that you register is just calling a macro called class db, I think, or gd class actually. You use a macro called gd class instead of the class that you're creating. And then that's gonna make it's gonna make Godot add your class to this class db and to the object slots every time you create a node. And the editor uses the class db to expose everything here. And the way that the properties of each thing are shown here is through this other macro called add property, which allows you to register the property of that class into the class db. And that's how Godot knows how to do stuff here. And then the stuff here, every time you do that, you need to, as far as I understand now, you need to create setters and getters, which are just functions from the class. They're going to allow ClassDB to understand how to change the value, update the value of the class. So that's basically what's happening here. And then every time you change the value here, it's going to show on here. So I'm pretty sure that the name of the functions are going to be similar to the name that it has there. But these ones are kind of weird, so it's probably just better to look for the function on the class directly. A set point, it's probably going to be set point, whatever. Then set modes. Set mode, I'm pretty sure I've seen already on CSGPolygon3D. And also seeing another function that determines how to get nodes. So the path that you put here is a node path, I think, class. A node path class is a class that Godot uses to track or to figure out where the node's at, as far as I understand now, on the tree hierarchy. So it allows you to pass a relative path, and then from the relative path, it traverses the tree until it finds the node, I think. But I'm gonna have to figure this out now, probably. And yeah. So here you go, path nodes, you select the path, which is the path you created there. Set path nodes. So this set path node is the thing that I think was kind of tricky last time, because it is not, you can't set directly the Path3D to this path node. On this function here, set path node, you can't put Path3D because this accepts as a node path class. And I think what the node path class does is just finds the node that you selected there on the GUI here, and then from that it gets the class. And I think I have here, it's probably here where this happens. I'm not 100% sure, but I think it is. So based on the mode, if you, after you put mode path there, it's gonna run this thing here. And this, I think, is where CSGPolygon3D is gonna build the data structure, or the structure of vertices that it's gonna use to build the geometry. So here, I think is the first time that it creates it gets the node that you selected there. So path node is the one that you probably set there on the function. Then it uses that path node to call this other function here. Then it's going to use the path node to actually get the nodes that you have there, and then it's going to cast that node using dynamic cast, because I think object cast is using dynamic cast under the hood. To Path3D, that this is going to be the class, and then it's going to use this class to actually build the vertices, as far as I understand now. Using this stuff here. And what they do is pretty much use array mesh, which is a class from Godot that allows you to build geometry using custom vertices that you have. So all you have to do is build these arrays or these vectors, which they do here, and with the information of each vertex. And then you call a function there called surface something, and then you pass the final array you build from the vertices that the array mesh is gonna need. But this part I'm going to study later. And so I think it's very simple to build the stuff here. So this pretty much is all the functions. So I think I'm gonna go on the Yankee there. Then after I go to the Yankee, what I'm gonna do, I already have the beginning, if I remember correctly, of the class that so the class I'm gonna create is on a module that I have there. I'm gonna explain how modules work as well to add your new classes, but basically, if you subscribe the class with the GD class macro and you put bind methods, you use the bind method function to register the methods of the class on the class DB as well, then it allows you to add the node from the class you created on the editor. And that's basically what I'm gonna do on a module that I'm creating. And the class I'm going to create is going to inherit from CSGPolygon3D. And I'm going to try to do this stuff here from the code directly. So, yeah, I think here, I have to see here as well, right down. So I think here is the points that they use to build the geometry here. And the thing is, it's kind of weird because they use only X and Y. So I think what they are doing is just building the two-dimensional face of the thing, and then the path is the thing that determines the translation and rotation of the geometry you build. So it's just taking that geometry and which is kind of different than the way that Blender does, because now I understand how Blender does, and Blender does the way that I was thinking about before, which is basically there's two different values of resolutions. I think is U and V. I don't remember which one is which, but one of the resolutions determine how many triangles you're going to use to build the circle geometry, which is like the face of this thing. And the V is how many sections you want to have along the curve. And what they do is pretty much create triangles that go from one face to the other, let's say. And depending on the resolution, it is going to determine how many of those things you have, which is going to make the line more curved or less curved. I'm going to show on Blender as well. And I think that this is probably better than what they are doing here. So I think, and this is like, there's several different paths to do this. So it's kind of difficult to think about which one to go with. But I think that this path is probably the best that I'm going, because I was trying to translate Blender to Godot, but they use different data structures, and I thought that it would just take too much time. Like it would take too much time focusing on stuff that doesn't matter that much. So I think that this path is probably better, but eventually I should probably try to see from the vertices and the faces how to actually translate the algorithm that they use here to create this curve to build in the same way that Blender builds instead of this one. Because here I think that they are doing more probably, but I'm not 100% sure. It might be the same thing. Yeah, so here it basically changes the. So I guess you can add a bunch of different points. So it is like I was saying. So each one of these points here is going to build the geometry, which is the face of each one. So the points here are basically building the face. So set polygon, I think. Yeah, set polygons changes the position of the points. So let's see if that is also set polygon. I'm just writing down here, so I look for the source code layer. So I think basically for creating a circle, all I have to do is just figure out how to do a circle in 2D. This is going to be a sine and cosine, but I don't want to spend a bunch of time thinking about this. Then you have an algorithm that creates a circle, then use that algorithm to build the packet vector true array that the polygon uses. Then you set that on the code, and then use the Path3D to set the curve. Okay, so I think that's pretty clear what I have to do. So now I'm just going to spend some time looking into the code. First, let me show the one, because I watched some tutorials and I realized that you can change the way that the view works there. But basically go here and you go on curve, baser, and it has the beginning. And then you can change the geometry of this by clicking here on data, which I've seen on, I went over this on a couple of streams in the past. But this bevel here allows you to add depth to the curve, basically. And this is the stuff that I was talking about. So there's two different resolutions here. This resolution here is going to determine how many sections they use along the curve to build the curve. And the other resolution determines how many triangles that they use to build a circle. So if you go here, I think it's here, wireframe, it allows you to see the actual polygons that they are using to build everything. So you can see that it is, but I think it's pretty similar probably to the way that Godot does it. And I imagine that this rectangle here is going to be just a collection of two triangles. So they do it, and the amount of these sections here is dependent on the resolution here. So if you increase, it makes more, which allows the curve to be more curved, let's say. It is still a discrete geometry, because it's the same thing that happens when you are converting continuous data from the environment into pixels. You're just translating something that is continuous into a pixel, which is a square. And that's the reason why the resolution of the screen is going to change how smooth the visualization becomes, because it's like converging to a limit that is infinite. You're taking data from the environment and you're putting on the computer, and the computer only understands pixels, so you have to do an approximation. And that's what is the same thing with the meshes here. So because you render everything with triangles, because triangles are the thing that are going to allow you to determine whether or not to color a pixel based on whether or not the triangle is part of the pixel or not, using the barycentric coordinate of the triangle with the edge function on the rasterization process. So yeah, because we render everything with triangles, you have to convert the geometry that is a continuous space on the environment into this discrete thing, which is a geometry that is made out of these things here, which are called faces, as far as I understand now. And the connection between the things are called edges, and the points are called vertices. And the order in which you create the vertices matter because of the way that the rasterization process works. So different frameworks have different orders, and then it determines whether or not the thing is facing the camera, or facing forwards or backwards. The order you add the points. So this makes it more complicated as well. I think here it allows to see better as well. If you click on the ball here. So these are the true coordinates UV, and there's also this, probably one of the best videos I've seen about this stuff as well. This video here from this person here, and they allow you to which is another thing that I was thinking about doing. I might do this now actually. So basically on the video they show how to build different geometries using this calculator here. And this calculator uses matrices. So each one of these is a matrix and you can add more of them. And then the combination of them just performs transformations on points, which is something that is kind of confusing to me as well. But like, the matrices are always used to do transformation on geometry, but usually the way you do it is you build the entire geometry on one part and then you do the transformation on another one. But it's basically the same thing. The matrix is just creating a polynomial equation when you multiply the point by the matrix, and that performs the translation and rotations on the points. And like it transforms on the whole thing because each point is being sent at once, like sequentially, point by point, but because all the transformations are the same for all the points, it transforms everything. But yeah, it's still not kind of confusing to me how to create the geometry using this. But I guess it's just the same thing. You encode the calculations for the differences in points on the matrix, and then you do the matrix multiplication. And then that generates like a massive equation that is used to create the connection of all the points based on the order in which you calculate each thing, I think. So I'm thinking that this pretty much generates a Python script that you can put on the Blender and then generates the geometry. So I created a file here on with Python, and I was thinking about just watching the video and reproducing the stuff that he puts there, and copying the script on the project and then transforming the Python script into a C++ function, and then seeing if the shape works. Because he uses a shape that is similar to curves, is a more complex curve, let's say. But I think I'm gonna do this after I figure this other stuff out. But that's pretty much all that I wanted to see here. So yeah, the idea is to build this from code now. So build this stuff from code, and then maybe eventually I use Blender. So I have to see if this is gonna compile here because of the Python file. I'm gonna remove, I think. So let me think about this. So I think the simplest thing to do for now, because right now the way that this is, and maybe I don't need to. So I'm gonna see if it compiles. So I have to close Godot. I'm gonna save this and close. Maybe I don't need to change anything. Oh, the other thing that I did that I realized is that I removed this as a property of another class that I have there because it was giving me some warnings, and I realized that I was doing things the wrong way, I think. I'm not 100% sure, but I think that's because I was thinking about adding the mesh as a property of this, but then I realized that this class here inherits from mesh instance 3D. And the mesh instance 3D already allows you to change the mesh that is selected. And the other class is just inheriting from array mesh. So it already shows there on the editor, even if I don't register that as a property of this class here. And I was doing this here, so I commented out, and then in order to expose the properties of this class, I just put the values here. And this is how you register the functions on the class DB, and the way you register the class is using the macro here. This allows the editor to have access to the class. So when you create nodes from the editor, it's going to show there, depending on the name of the class you have here, and the methods and the properties. But yeah, so let me see, because I think I don't need to change. The way that I was doing this is so that I call the build curve one time there, because this is the class that I'm planning to do the line 3D mesh. And I want to do directly from the array mesh, like I said. So, because I think it simplifies everything. I don't want to have to deal with other classes. Like the final thing that I want to get at is a function that accepts two points, source and a target, and then based on the number you pass to the function, it's going to produce different Bezier curves, which I'm probably going to do in enum, so that I can build quadratic Bezier curves or any other type of Bezier curves based on the source and target, and without having to use other classes, just having access to the vertices directly And that's what I'm trying to do. But now, in order to test this stuff and to do the other stuff, to study the CSGPolygon3D, I'm going to create another class so that it is not, so I don't have to change this one that much. But another thing it matters that this is creating the function, is running the function that I have there, because all I have to do is not add this class to the editor, just add the other CSGPolygon3D. So I think this, so I'm gonna leave this as it is now. And now, so I think, yeah, these are the classes that I started doing now. So let me think about it. So I think the first thing is to figure out, so yeah, I have to find Path3D, curve path. So basically I'm gonna do the same thing that I did there on the, or try to do it from the editor. So which way? I'm gonna close. Oh, this is the other stuff that I was thinking about. I created a folder on math, on Blender called math. And I was gonna do the, I'm not really sure if it's worth doing this. So I'm gonna see later. I'm just gonna close this stuff here. So I'm gonna close, I'll close everything else. Well, I have to register this class. So I think first, before I do anything, so the first thing you should do is to put this stuff there. But before I do anything, I'm going to see if the class shows up there on the editor. I'm gonna forward declare this. So Scene3D Path3D. This one I don't remember how I was doing on the other. I'm just putting edge mesh here. It's Brahma graph. I think it's if it works, it's probably better to do from the top, I think. Or do I put on modules? I think the way that I was doing before is the relative path from the module. So maybe I should explain how the module works. I'm gonna close this other stuff here for now. So the way that the modules work on Godot is that you have this folder here called modules, and then you can, any folder you put here, you can put this other, there's stuff on the documentation to explain, but these two files here allow you to register whatever you want. And the name of the functions have to be the same name of the folder you create inside of the modules. And then somewhere along the setup, I think, function, what Godot's gonna do, I think it's probably on the compile time, the compile parts of the process. Godot's gonna generate a file that is gonna have a bunch of functions that are based on whatever folders exist inside of the modules, which are gonna allow Godot to, on the runtime, to call these functions here at different parts of the cycle in order to initialize the modules. And all that these functions are supposed to do is based on the level you put here, which is how much access your module needs from the engine, which are 4 different ones: core, servers, scene, editor. I think there is a hierarchy, so that's why I wrote like this. So I think core is the most essential part, and then editor is like the most high level, let's say. So a lot of modules probably don't need editor, but most probably need the scene. So the scene level would be like this stuff, all this stuff that is created on the Scene3D, or on the scene folder probably, so on this path here. And there's different builds from Godot that don't necessarily build these other files here. So if you don't specify the correct level, then it might break the module, depending on the way that people build stuff. But then after you put the level here, it allows you to use this macro, which is basically just going to register the class on the class DB there. That's going to allow the editor to have access. So you can build whatever class you want. And as long as you use this stuff here, it's going to expose this class on the editor, which allows you to add your own custom classes to the visualization. Yeah, so I think this one I'm going to have to import there, or to include. So basically just put the name of the class. Yeah, and all of that this does is just call register class from class DB with the M class, which is your class name. And this is gonna put the class on a global object that they use, which is called classes. They register all the types that Godot uses. So I think, yeah. And for now, I'm putting the relative path. From the folder of your module, you put the relative path to the file. Oh, and the way that you add this, actually for modules, I think is probably, yeah, they do it. Oh, but I think you have to put this CS sub here on the root of the module or the folder, the module you create. And the CS sub is the file that Scones is going to use. I'm not sure if I changed there. Maybe modules. I don't remember at all. Yeah, so it's pretty much adding the all C++ files through module source. It's kind of weird now that I think about it, so I'm not really sure. Oh, it's probably, maybe it's because of the config? No. They talk about this, oh yes, because I put here. So usually the way that they do it on the normal C++ files from Godot is that they create a new SC sub on each folder, each level of the folder, and then just put somewhere along the line, you just put this line here that adds the source files to the environment. And then the star operator gets all the C++ files on the current directory. And Scones figures out the dependencies based on the C++ files. So all the header files are included based on the C++ files. So I don't need to specify. But here I did this way. I'm not 100% sure why, but yeah. It's pretty much the same thing, just specifying the relative path here and that's SC sub here. And I think that for modules they already have, they already created on the main sconstruct file that Scones uses to create the build system. They already create a code here probably for the modules that are just gonna look for the root SC sub on the module. So you don't have to specify, but if you want to create other folders, which is what I did there on the Blender, all you have to do is just change the, you just have to add here. So this sconst script inside of the sconstruct file is gonna tell sconst to look for to run the whatever file you put here in the same way that is running sconstruct. So this basically has the same logic. So I just copy it from the way that they do it there. So for each main module that I have, which is the main subfolder that I have there, they put another SC sub. Then on that, they have Python logic to add other source files to the build. So if you want to create your custom one, you just follow the same thing that they do there. Just add CS sub on the root of the folder, and then just add. So I think that's all that I have to do here. So I'm gonna test to see if it compiles. I think it's probably better to test first, then open the thing. So it's probably because of the relative path. This part's kind of annoying as well because of the way that C++ works, because of translation units. So usually people recommend you to put this stuff here or put pragma once, which is basically the same thing. And what this does is it stops the header file from being added twice, but the problem is that it only stops on a translation unit. The translation unit is just the C++ file with all the headers that it depends on because of the compilation process. So the first thing that happens on the compilation process is that it runs the preprocessor, and then it creates the object files. And like each C++ file is like an island, so they're not aware of each other. So it doesn't matter if you have this stuff here. If you're adding the header on two different C++ files, it's going to add the header twice because the linker is the thing that connects them, and it happens after the object file was created. So I never know what is the best way to do things here. And I think this is related to the paths there because it's related to the build system as well. So here, like, it seems that I'm just using from the same folder. So I think that's, yeah. I'm not sure if that's the best. So I do think that there's two different. So probably the relative path here is determined based on the way that you configure the CSC subfile. So because I'm adding this line here on the includes thing, because this cons is going to be the thing that figures out, I think, the imports, the includes for each C++ file. So I think whatever relative path here you put allows you to consider it as the root thing from the file. So here I could use without the graph. Not sure if it would work, but I'm not sure if this is the best way to do it, because I think the other approach is just to do it from the root of the whole project, so modules, Brahma, and stuff like that. So maybe I should look for, I think I spent some time thinking about this on some other stuff that I was doing, but I don't remember which conclusion I got to. I hear they just put in the relative path. So maybe it doesn't matter that much putting like that. It's probably might be because of here as well. I'm pretty sure I had this problem some other. So maybe I have to, maybe just declaring. But I do remember something like this as well. And maybe this is why this is not the first time that I thought about this relative path stuff. I think it's because I was trying to include the other files on the graph file. Trying to include the nodes and edges on the Graph3D and then register them on the register type, and then here I'm just including the Graph3D and I'm not including the other ones because the other ones are included through the Graph3D header. But I'm not. This part is like very confusing. So maybe if I just, I think I'm gonna copy from the other. And then here, just delete everything. I'm just creating this class just to test to see if it's gonna work. To do everything from code. Then once I figured it out, then I think it's probably better to try to do it. And this is something I was thinking about from the Blender thing as well, but I'm not really sure if it's worth it because of how hard it's gonna be, and if it's just better to fix this stuff because the main reason why I'm doing this now is because I'm probably gonna use the Curve3D for the stuff that I'm trying to build, which is gonna be a graph on a 3D graph using Godot. So after I do that, I think it's probably better to spend time trying to do that first. Then I think about whether or not, because it can get very complex to do. But I think I'm gonna have to understand this at some point anyway. So it does make sense to spend time thinking about this. So I think it's worth it now to set things up in a way that is gonna allow me to in the future look for this, and that's partly the reason why I want to extract all the functionality from these classes into the Blender folder, into this folder here, the custom folder, and probably on the map as well. So that way I have like a framework inside of Godot that I can use to build custom geometry based on the stuff there. So it seems like it works here. So I'm gonna do the Enki thing now. It's just the pass here. I have to see. I have to think about whether or not it matters. So I'm gonna study Path3D first, probably. I study Path3D because I'm gonna initialize everything on the constructor, I think. So I'm not really sure if it's worth it to, if it's better to consider Path3D as an object and then use memu to allocate memory, or to use the math class to consider it as a resource. It probably makes more sense to consider it as a resource, and then just instantiate on the constructor, then call the function from CSGPolygon to set. I'm gonna probably have to create a node path. So yeah, I should have node path there instead of probably both actually. So initialize the Path3D. I'm gonna write down the steps there. Oh, so it does show here. Nice. Yeah, so now I'm gonna spend some time studying. I'm gonna do the Enki thing first, and then I'm gonna study it. So first, let me do this. Curve node path, maybe. So just include this file. I'm gonna close all the other stuff here, and then start from the beginning. So I'm gonna forward declare, and this is the reason, the whole stuff about the translation units, the reason why a lot of the times it's better to do this forward declare here. So what this allows you to do is to tell the compiler what this is before it compiles all the way, let's say. So it allows you to not put the header inside of another header file, because that's usually when you have problems with including multiple different translation units. So the thing that usually people do is just forward declare this stuff here, and then they include the header here. And that allows the compiler to, on the linking process, to find actually the definition of where the thing actually is without creating conflicts. But based on the other classes I tried to create, it seems that you can't forward declare for the main thing that you're gonna inherit from. So you have to include on the header file. And it might be different, this whole thing, when you're using scones because of the way that they build the translation units, but I'm not 100% sure because I didn't spend much time studying the source code for scones. So I'm just gonna include this car string node path. Yeah, so now let me think about this. The problem here is I'm not really sure how to go about getting the path, because it's gonna be a child, so I'm not gonna I'm gonna ask ChatGPT probably to figure this out. So I'm probably gonna build from this thing here. I might not need to create a class, just yeah, but it's probably better to have the class here. So what I'm gonna do is just on the constructor here. So I'm gonna write down the steps that I think I have to take. So first thing I'm gonna do is probably study Path3D. So yeah, study Path3D. I'm gonna put the steps here. So instantiate Path3D. I think I'm gonna do it as a reference because it makes more sense. So include the ref thing as well. I think I had a problem sometime using this. Oh, it's because I have to use the template there probably. So when you forward declare with the template, you also have to forward declare the template. Object ref content. But I'm pretty sure I had a problem with this at some points as well. So I'm gonna see if it works. If it doesn't, then obviously I change. Fuck. So the first thing you have to do is instantiate the path, I think. Instantiate Path3D and add points. So I'm probably gonna have to, so I have to see. It's probably gonna be a vector tree. So this stuff, I'm gonna have to, based on the study, I'm gonna put vector tree here. And these are gonna be the points of the Bezier curve, but I'm just gonna put random points now to just create a bunch. So instantiate, then add the points to the Path3D. Then set node path for CSGPolygon3D. It might be better actually to. So before I set the path, I'm just gonna set the points, the face points, or CSGPolygon3D faces. To create circle geometry. I think I'm not gonna do. I probably am gonna have two different resolutions, which are gonna be floats, like I said before, based on the. I think on Blender they use Resol U and Resol V. So usually people use U and V, I think, to determine. I'm gonna ask ChatGPT which one is which, because I don't remember. Yeah, but one of them is this one, which is the shape, and the other one is this. I don't remember which one is which. So here render U, so this is probably the U. So U is on the U is the sections. I'm gonna put default values. I think Blender they use 1212, if I remember. So assess the path here. I think that's pretty much it. So I'm gonna do the Anki stuff, then I'm gonna start studying the. I have to include the vector. Core math vector 3D. Core math. So I'm gonna compile and see if it works. I'm gonna do the Anki thing here. I think it's gets history. Maybe just history. Don't remember. Yeah. This one I never know if it's item or objects at the end. Just with objects. I'm not sure if it's history or age. It's just age. So this I don't remember if it's like this as well, but select objects. I'm pretty sure it is. First three. I'm not sure if it's new or invoke. Invoke Rust methods. Maybe it's new. Oh, it's invoke. Yeah. It's sync 32. Error. No. Yeah, I think it's error. You cannot call methods on a valid expression. Yeah. I think it's gets contents and path, file path. Oh, yeah. It's force. There we go. Pretty sure it's like this. Oh, there we go. Invoke commands. I think is gets commands. Yeah. Don't remember if it says because on the bash playlist, I think bash cards, it puts command and then file. But I'm pretty sure it's this operator. It bugged, so I can't say. Declare a variable named int. I think it's like this. Int num for the true. 5. So this is I think it's regex and then pattern goes hello world. The only downside of this is that I didn't build the cards, so they are kind of generic, and I'm not really sure if it helps a lot because it's not the commands that I would probably use. But I think it does help to increase your baseline so that it becomes faster if you have to use it. Have to create something, you already kind of have an idea of how things are, and it doesn't take too much time. So try and catch. Send its contents to the path contents. Don't remember which one is which for this one. This one I don't remember really well, so I'm not really sure if it's like this. Yep. I think it's the other way around because using path like this doesn't make a lot of sense. And probably, so it's probably like this: gets contents, outputs, path, file path, encoding, UTF-8. This one I didn't remember. Out file path. I'm gonna stop here. So 33. A lot of times I wish that you would allow me to see from a certain point. But sometimes I don't want to just write down after because I'm not really sure if sometimes I do this on the morning and then I'm not really sure if I'm going to do it later on. So I don't want to write down and then I end up forgetting. So it's kind of annoying because there isn't a way to see, like, to accumulate everything, I think. And maybe it shows here somewhere because this is a plugin, I think, for Anki. It just keeps track of all the times you did. But I don't think it shows everything that you have done. Maybe I can search for this later. It's gonna be 53. Once I get to 4,000, I think again. I'm probably gonna go faster on this one because it seems kind of redundant on most of them. Some of them I forgot, but most of them I still remember. So I'm probably gonna do just 200 more, like press 3 so that they don't show frequently, and then just do the ones that I forgot a bunch of times again. Then move on to the other ones and iterate again. So maybe it's just better to use. I forgot to see what Path3D inherits from. Everything inherits from objects, but yeah, so Path3D is not supposed to be a resource probably. Because the ones that are resources inherit from resource, and Node3D doesn't inherit from resource. So it's probably meant to be used as a class instead of a reference. Used as an object instead of a resource. I'm gonna put another hour here. So I'm just gonna remove the reference. So when it's used as an object, you use memnew. And then you create a pointer. For the same reasons I said before about this definition here, it's usually better to define things on the C++ instead of the header file to avoid multiple definitions. I think multiple declarations don't matter as much, but I'm not 100% sure about that. But I think definitions is where the problem is at probably. So if you define things on header files, increases the chances of having conflict with the includes because of the linker, stuff like that. But I think here it doesn't matter that much because I'm just gonna, after I build this class and I see it works, if I'm able to translate to the other one, then I'm just gonna use the other one and delete this class. But even if I'm not able to translate all the functionality from the classes into the other stuff that I have there, into the other function, I'm definitely gonna translate. I'm gonna change the other class that I have, which is the line 3D mesh. So I'm probably not gonna use this one. I'm just using now for creating now to understand how everything works. So yeah. So curve path equals memnew Path3D. I have to remember where the memnew is from. CorelS memory H. Memory H. So the question is how to add the points here. You have to use a Curve3D. It's kind of annoying. Maybe you don't have to. So Sync3 is the main class that they use to create the node hierarchy that is gonna create the visualization. Set 0.0. So maybe what I have to do is create another class called curve, then initialize curve, then set the curve here, and probably you set the points on the curve. That's why, I guess what I can do is just look into the add property macro, because this is gonna allow me to understand. And this is path follow. Okay, Path3D. So the editor exposes the thing there to this stuff here probably. So I think I have to do this. There's probably So you set the points on the Curve3D, probably, and then you set the path with the Curve3D. It's probably a graph, Curve3D. And I have to include the thing again. Actually, I'm just not copying. And then here you instantiate. This initializes the reference, I think. It's probably, it calls the constructor, I think. It calls the constructor for the Curve3D. And I have to include the Curve3D there. Seeing resources, Curve3D. So set the points first on the Curve3D, then you set the curve on the Path3D. Then it generates. I'm probably going to create another function to generate the points. Generate a sphere. No, it's not sphere, it's a circle. So I have to see how to create the thing here. So let me. I think it's just set curve. Yeah. I'm going to create two different functions. It's not protected. I might have to change, obviously. To generate circles. So the first one is probably a curve points. So now I have to see how to. So here I'm gonna call generates curve points. So I'm gonna use the curve to. I'm not gonna check to see if I have the curve or whatever. I'm just gonna do the simplest thing possible that I can think and see if it works. To generate the points, then generate the thing. And then here I set the path. I have to. So I have to add as a child as well, I think. So adds the child's square path. So the curve path is going to be a child of this node here, or this class, which is this. So the main question I have is how to, if the path to this is going to be, like how to initialize the node path class. So if it's going to be like this, or Path3D. Because I think I need to have the string with the relative path from this node to this node here in order to be able to initialize on the other thing here to pass the node path. So to initialize node path, I need the relative path to this node from these nodes, I think. Then I initialize the node path, and then with the node path, I change on the CSGPolygon3D, and then it's going to use this curve. I think that's how it works, but I'm not 100% sure. I'm going to focus on this other stuff first. The first thing to figure out is the points here, how to set the points and what data structure. So I'm probably gonna do like 4 points. So look for the data structure first, then create 4 points, then set the points here. So I'll be right back. It's probably easier to look here. Points. So I think it's just the first value you need to set. The other one has yeah, the other one have the default value. Just an empty vector. So it's gonna be I'm just gonna put some random numbers here. And then I'm just gonna show the curve. So, okay, now I have to figure out how to do the circle. So I'm pretty sure on the line mesh 3D I had the calculation for doing a sphere, so maybe I'll take the inner loop from that one. Or ask ChatGPT. Should do it. This one. The problem is I think this one doesn't work. So I have to see how to. So I have to study the. Let me see. Circle. I have to study the SCG polygon first to see how they do it. So it's sat polygon. No, here. This is a vector 2. So I'm just gonna ask ChatGPT how to the function to create the circle. Sir. I don't understand this. I'll add the first point again. Should close the circle. I'm not 100% sure if this is correct or not, but it doesn't matter. So sets polygons, set polygon. And the number of points I'm going to change for resolution V. That's 50 on this. So I think that's pretty much it. So set the polygon, passing vector, vector true. So I'm creating the points, and then creating the points and then setting on the polygon. Okay. So I generate the circle. Now is the annoying parts. So I have to see node path. Maybe I shouldn't have as a member variable there. Should just initialize and then send right away. So I forgot which. I think set path. Yeah, set path nodes on this one. So set path nodes. I think it's just easier to do like this. Or just say string. Or string, use string. string, new string, string, new string, string. So this is the part that I'm not sure if it is like this. So I'm gonna ask ChatGPT. So this is how you test whether or not the reference is valid. Maybe you should put this there as well. Reference. I'm gonna try to do it in the way that ChatGPT does there. So the problem is this name here. I'm gonna see if it worked. Oh, I think I can. There is a function inside of the GD class macro that allows you to get the class name or the but it allows you to get the class name, not the path. Maybe there is a function to get the path inside of the macro and Path3D. I'm not really sure if Path3D is subscribed. Yeah, it is subscribed on the macro. So I'm gonna ask that to ChatGPT if there's any function. So it did create the circle, but it didn't create the path. Oh, I forgot to set the modes. Hmm. So it's both the path that is incorrect. So let me see how to. It's probably just set modes. Yeah, set modes. Then create this thing. So this is incorrect. So I'm gonna ask if there is a way to get the path from the macro here somehow. Hmm. I'm gonna try this one first. Pretty sure if you don't put anything when you initialize classes on C++, it's just gonna be the name of the type of the class. So it would be Path3D. So maybe if I just put Path3D without this stuff here, it would work. But I want to try this thing first. Path3D, because it's what ChatGPT is saying here. Also, it's saying to start the path here. So maybe I could do this as well and then just use there. Let's try this. The challenging part is going to be to understand how it's probably going to be on the function of the array mesh that the CSGPolygon3D creates the final mesh based on the path. But obviously, I'm going to have to spend a bunch of time understanding how it's going to use the Curve3D. It's probably on the function that I was looking at in the beginning of the stream. That it decides it does a control flow based on the modes, and then it gets the curve. But from that function, it's still not very clear how does it work there. So like, what is the calculation that it's actually doing, and what data structure is actually using to build all the points that are going to make up the final geometry? Yeah, I have to figure that out. Then once I figure that out, I can just try to extract or to do from the data structures directly and implement on the other class that I have there. If I'm able to make that happen, then I think it's probably better to do that first instead of doing the function for the Bezier curve. So just see if that works, then translate into the. I see if it works with this class, then do it from the fundamental data structures. Then once I have that, interesting. So I do think it worked, but it's just fucked up because of the points. And because probably the path there that I did is weird. So obviously what I can do, so there's a bunch, there's two things that I can do. One is change the values, the other one is to register the properties of the class into with the add property macro so that I can change the resolution from here. I think it's easier to, but I do think it worked. It's kind of weird though because it's showing the points here. So this is the part that I'm not 100% sure. So I'm gonna delete. I'm just gonna not save and then I'm gonna change the values. I think it's the value of the radius that's big. Let's put 5. So I'm just gonna do a straight line, I think. Just put like 5 here. Do 0 on the z-axis for all of them. It might be because of this stuff here. Not sure. So it does work, but there's something weird with the first points there. I think it's just the orientation of the points on the first. So what is happening is that in the beginning it creates the circle, like assuming this position there. Because it probably, yeah. So like the first one is on the incorrect place, and then the other ones just follow the path of the curve. Yeah, but I don't think that matters that much. So let me think of this. Now I think either way I'm gonna have to, like, it makes more sense now to just focus on the. So obviously I think that this is probably enough. Like if I wanted to create the Bezier curve from this, all I have to do is just create another function here, and then the function creates the Bezier curve. Then you put the source and target, and then you do an enum that determines what kind of Bezier curve you want, which is just the difference in control points. Then on the algorithm, which is going to be the function that creates the Bezier curve, you pass the enum, and then do a control flow to create the function that is going to create the points. Then once you do that, you just update the values of the member variable here with the curve points based on the Bezier curve, and the rest is probably the same to create. So I think this is enough to create a 3D Bezier curve with Godot. But like I said, I think like what I want to do is just remove the. I wanna remove the classes, the Curve3D and the other one, and just use just do it from the data structures. So they use a vector to create a face, and then the curves, the points on the curve are, it's pretty much I think it's, yeah, it's similar. And the question is, I think that so there's another thing which is the cap here. So this, it seems that it is, seems like it is closed here, so that's the thing. I think it might be the biggest difference if it is like this. Like, because what might be happening is that they create a surface, and then from the surface they just put a bunch of them together through the path, which is not very good, because the way that Blender does it is they create the actual surface instead of creating the whole thing. So like they create the points of the circle, but then they use the distance between two different circles to create a hollow tube that doesn't have anything inside. And the vertices to create the triangles are just creating the surface based on the difference and the two different resolutions that they have. So I think that's more optimized, but it becomes more complex to do it. So what I have to figure out is whether or not they do it like this, which I don't think they do because of the way that it seems like they create there. Like it seems that you create the surface first using the Vector3D on the polygon, and then it's just gonna take that surface is gonna iterate over the path that you put on the Curve3D to create the geometry. So yeah, but what I think it makes more sense to do is just try to translate, extract everything and just put on one algorithms, both the Vector2D points to create the surface and the points to create the curve. And see. So that's what I'm gonna do now. I'm gonna study how do they generate the geometry on the CSG polygon. Interesting. And the problem is that this doesn't have curvature because it's a straight line as well. So there's another issue. So let me think about this. Because I think that the smoothness of the curve on either on both on Blender and on there, it just happens because of the amount of sections you have here. But the thing that is kind of confusing on Blender, and this is kind of the part that I wanted to clarify as well, is like how does it calculate the rotation in 3D? And I think it does that on Blender because it keeps track of the previous point and the current point, uses a linked list of data structures using a C pointer, and yeah, using C pointers, it has a data structure that is a linked list that keeps track of all the sections here. So this is a linked list, the thing that connects the sections. And it keeps track of 2 at a time on each part. And I think that the way that it calculates the rotation, whether or not it needs to rotate, is based on the difference in direction of the vector. So, but I'm not 100% sure like how that works, because in my mind you need at least 3 points in 2 vectors, obviously, because then if you have the 2 vectors, then you can compare, you can get the angle of the 2 just doing triangle math, obviously. To get the direction of one and then the direction of the other one, and you see if there's a difference in one of the directions, and then whatever direction there is a difference, you take that difference as the angle, and then they use quaternions, I think, to do the rotation. And that way you rotate the circle. But this part's the one that is the most complicated, so that's the problem there. So I think one thing that I can do is just get the points from this here to create the curve there, because I do remember how to. It's not that difficult. So I can get the same points, then transfer these points into the curve that I have there. The only problem is that because this is a Bezier curve, there's 6 different points, I think. And I think that probably 3 of them is just going to be control points that are probably outside. I'm not sure. Bezier curve is probably inside of the curve, but it's just handle points to create the shape of the curve based on the linear interpolation. So I think on the other one, if I want to create the same, it just gets the 3 points that they use here. Because I want to see if there's a curvature. If they do curve based on the shape of the. So that's what I'm gonna do. I guess I could just think and put here the values, is easier. Let's see, 0, 0. This one is gonna be like minus, let's put -5 and 0, 0. This one 0, 5, 0. I'm just gonna do X and Y direction. And this one 5. So let's see if what this creates there. I'm gonna decrease the size of the radius as well. I suppose it's true. I guess it depends on the resolution you put here. No, it's not this one, it's the other one. So this is the thing though, because the thing is gonna be created by the curve. So I guess the polygon has to determine the resolution. It depends on the way that they do it, that's the thing. So because in the way that on the function that the CSGPolygon3D uses to generate the whole mesh, it's gonna be the thing that determines whether or not they do the same stuff that Blender does, where they create a bunch of sections based on whatever geometry you put there. So they would have the same resolution that Blender has to create the curvature, which is based on the sections, or if they do something else. So I have to spend some time studying the way that they do it there. Interesting. So they just split by 3 here. It does kind of create a curvature. Hmm. Doesn't seem like there is anything here to change. A path interval. Ah, here. Interesting. So the path interval is the thing that determines. So what they call path interval is probably the same thing that's Blender calls resolution U. And now it broke the thing. Okay, so I guess the minimum is this value here. Oh, so I see what's happening, I think. So like it's the same thing that happens on that they say on the basic curve is that I think it's the same is exactly the same thing. Is the like the interval that they say is that they are just dividing the curve and it's based on 0 and 1 because that's how a Bezier curve works as well. Because Bezier curves is based on linear interpolation, so linear interpolation is going to be basically the ratio of the distance of the points, the control point in the middle of the line, let's say, and between the two different points you have to create the linear interpolation. So the amount of intervals you put can be viewed as the same way of the amount of weights you have on the curve. So it's basically the same thing, I think. The path interval there is equivalent to the resolution U here. It's how how much you're gonna subdivide the whole path, so that each time you create a structure based on that. So I think it's the same thing. So here, and these weights go from 0 to 1 because it's like in percentage, I think. So the whole distance would be 1, which is 100%, and then the amount you put there is the amount of lines you have. So I think that's why. But it's weird that here, even if you go by 1, it doesn't create like a straight line in the same way that Blender does. So it seems probably slightly different. And the other thing is that the first circle is creating on the origin here, which is kind of weird. But I think that's probably going to be easy to figure out. So what I'm going to do now, I'm going to stop streaming now, but what I'm going to do is just study I'm going to study how CSGPolygon3D creates I'm just going to show because I probably know roughly how it works. So here they have a base mesh. I'm not really sure if it's on this class or on another class, but I do remember seeing here somewhere. I think it's on the brush, yeah. So they probably use this brush here, CSG brush, to draw this stuff. And this CSG brush has a mesh, which is the root mesh, which inherits from, or is itself an array mesh. And then they probably build the geometry on the same function that other array meshes use to build the geometry, or other primitive meshes use. So I'm pretty sure that they use the CSG brush to do it. Obviously, I don't know how yet, but maybe somewhere else. So let me see if I find by the name here. Yeah, root mesh. So the root mesh is on the CSG Shape3D. And the CSG Shape3D is used somewhere along the line there on the CSG polygon thing. So they probably built from this root mesh here, which is an array mesh. So they use the surfaces that you build from the curve and the vector or the array that you create for the surfaces. So I just have to find the algorithm that they use. Sure. Where is the function? And then once I find where is the function, I'm gonna be able to understand how they use the data to create the final points. Then once I figure that out, what I can do is just extract everything and just try to create it directly from the array mesh that I have on the other class and see if that works. Then if that works, then what I'm going to do is just spend a bunch of time thinking about I'm going to see if I think it's probably the same way that the Blender one works, but I'm going to spend some time clarifying whether or not it is the same. And if it is the same, then all I have to do is just create another function that is going to create a Bezier curve based on source and target points and the amount of control points that I want, which is probably going to be based on the enum. Then once you have that function, you just get all the points that you need based on those ones on the constructor, and you put as a member variable of the class. Then you use those points to create the final geometry based on the other function that creates the circle, to this circle, and interpolates the curve based on the resolution that I have here. So I think that's what I'm gonna do. Then if I'm able to make all of that happen, then I'm gonna think about whether or not it's worth it to. I probably am going to spend a bunch of time at some points studying, but I'm not really sure if now is the best time or later, because it might be better to just use the curve that I create to start building the graph and building other stuff, and then come back to this at some other point. But I do want to clarify and study the other library there, Geometry Central, and also study or clarify how a mesh generation usually works. So yeah, that's probably what I'm gonna do next. And yeah, not sure when I'm gonna come back, but obviously I'm gonna continue to build stuff with Godot. So